we wanted the ability to take code, put it in a container, and execute it in the cloud in less than a second. Because that's when I feel like that's when you have this like ultra fast like feedback loops that make you happy as an engineer. The idea is almost like you write code and the code defines, not just like what happens, like the application code, but the code itself also defines its own infrastructure.
Welcome to the Highlight Podcast, where we interview technology builders to talk about the joys and travails of building products. Today, we're talking with Erik Bernhardsson. Erik is a lifelong programmer and the founder of Modal Labs. Erik was early at Spotify, where he built the music recommendation system before joining Better.com as CTO and eventually founding Modal Labs. Modal.com provides serverless cloud functions for high-performance workloads running on both CPUs and GPUs. Developers can iterate quickly on their local machines while running compute-intensive jobs on Modal's cloud.
Let's get started. Erik, good to have you. Thank you for joining. Tell us a little bit about your background. What led you to start working on Modal? And then we can kind of dive in from there.
Yeah, of course. And thanks for having me. So real quick, my background is I grew up in Sweden, studied physics, got into computer programming pretty early. And I got into, in particular, I was doing a lot of programming competitions. Through a bunch of people I got to know from the programming competitions, a lot of them went on to start this early stage startup that was doing music streaming called Spotify.
Okay.
So I joined Spotify early on in 2008. Ended up staying there for roughly 7 years. In the process, I moved to New York at some point. So at Spotify, I built the music recommendation system, among other things. I was a little bit like everything data related. I did a lot of like business intelligence, but also a lot of like deep learning, collaborative filtering, large scale like numerical methods, like everything in between. And then I ended up working 6 years as CTO for a fintech company called Better, which was its own kind of roller coaster story.
Yeah.
Left towards the end of 2020 to start my own company, Modal, which initially was just me hacking on stuff. But pretty quickly I realized like what I'm working on makes a lot of sense. So I started building up a team and talking to VCs and all that stuff.
Nice. And then how has the idea from Modal when you started hacking on stuff to when you started to really realize it as a real company, how did that change over time? Or how did the idea change,
Yeah, I actually think, I didn't start with an idea as much as just like, I want to build better tools for data, AI, machine learning teams. And actually that's like kind of a minor piece of advice in general. Like, I feel like worked really well for me is like not getting too focused on like a particular idea, but more like a domain, a problem, and an ICP and a set of like problems together that deserve the solution. And I started looking at like the whole stack initially. I was like, I just want to build a better data stack, which is like borderline megalomaniac, right? Like the data stack is very large. There's so many different tools and so many different boxes, right? And so my second question at that point was like, okay, where do I start? And initially I was like very interested in like workflow scheduling. I ended up building open source workflow scheduler a long time ago called Luigi, which no one uses today, but like prior to Airflow, a lot of people used. So I looked at that, but then I realized actually like what is more interesting is the layer below, like the compute layer. And what I realized was like that is a very broken part of how data teams, and I say data teams like kind of liberally, I also mean that to include like AI, machine learning, whatever, how they operate and how to productionize and scale like that. At the end of the day, like you typically have to write code and you have to run that code in the cloud. And that just turns out to be very annoying experience. So I started focusing on that problem and then pretty quickly realized that in itself is a very hard infrastructure problem. And I'm going to have to, realize I had to go deep in the layers of containers and file systems and Linux and cloud. And yeah, that's what, basically I've been doing for the last 3 years now.
Very cool. Very cool. And so I'm curious, I'm pretty familiar with the Airflow. Prefect is another company in that space. Is that true?
Prefect, another one's Dagster.
Yeah. So I'm kind of familiar with how those types of things work. And that's basically like a data engineering team wants to do like a multi-step set of things and have complex tree of what happens in what order and things like that, right?
Yeah, exactly.
How does that fit into your world of Modal? And do people... is that like a superset of what Modal does? And Modal's
no, it's actually somewhat complementary. And we ended up actually doing a kind of working on a partnership with Prefect recently, where like in a way what Modal does is like the complete opposite, which is like, Prefect focuses on orchestration and like stitching together these like steps, right? But then where do you run those steps? Like Prefect actually doesn't really have like a strong point of view. And of course you can run them in Modal. And so like we actually did a small, partnership together. But in general, like that's kind of what I ended up realizing also, like when I was looking at like the data spaces, you got to run code somewhere. And like, typically, at bigger companies, like you end up running it on like something like Kubernetes, and now you spend all your day like writing YAML. Or at a smaller companies, it's like, okay, well, I guess I have to go set up like an EC2 box or use AWS Batch or something like that. And so that's what we started working on. And then a kind of a year and a half in, we barely had any users, any revenue, and still hadn't really figured out quite like, okay, well, what's the like killer app use case? Like we felt like we had like a kind of a good platform in terms of like running compute in the cloud. But then suddenly a lot of people started coming to us and they were like, hey, like, like we have these like Stable Diffusion, the Whisper, like all these like Gen AI stuff started happening. And people started coming to us and they asked us, can we run this on Modal? And we realized actually for a lot of reasons, like we had a platform that worked quite well for those use cases. So that's now like the last year and a half, roughly. That's what we've been mainly focused on in terms of like what's been driving, user growth and traction.
Very cool. Very cool. So if in a few sentences, if you're to describe, Erik, just to close the loop, what Modal does, what is that, and what does your customer look like?
Yeah, so Modal, basically, like architecture, you can think of Modal as AWS Lambda, and it says we're function as a service. However, Modal also comes with a Python SDK. So the idea is like you write code in Python, no config, no YAML, and in Python, you basically, define functions and you say, I want to use these packages or install these images or use these types of GPUs. And then you can deploy it to Modal or run it on Modal in a number of different ways. And we handle all the running. And we're a cloud provider in the sense that like we control, we have, hundreds or thousands of GPUs in our account that we run everyone's code in. So the idea is like, instead of setting up AWS, like we can just like run it for customers. And we charge then our business models, we basically charge people based on that, like the number of milliseconds the compute runs, right? So it's purely usage based in that sense.
The other question I had on the Modal side is you mentioned the Python side of things. How does that map to the infrastructure that gets run under the hood? In the sense that, okay, I'm imagining I write, I have a Flask app and I want to run. Okay, maybe this is a bad example, so feel free to tell me this is a terrible example. But I have a Flask app, and one of the endpoints I want to run against a GPU. Like I want to run inference against some model or something, right, on a GPU.
Yeah.
How would that work in the Modal world? And then, assuming I can add some code, what gets scheduled when, and how does it work with my deploy process and all that stuff?
Yeah, so you can run an entire Flask app on Modal. That's not what typically people do all the time because Modal is more meant for like compute heavy, like things that, it adds a little bit of latency. We start containers and every function calls. So, but so the way you would do in that case is you would define your inference model, like you would define a model in Python. And it's like, 30 lines of code or whatever. Like you basically say, I want to use this GPU, I want to use this image, like this is what the inference does, import transformers, import diffusers, like etc. And then you would run a command of like Modal deploy. And, now you get like an inference endpoint in the cloud. And then through the same Modal SDK, you can just do like, you can get a reference to this Python function. And you can call it just like a normal function. But under the hood, like you call it like a function from your Flask app, it actually gets, the arguments get serialized. We send it to the Modal cloud. We execute, spin up the GPU, spin up the container running on the GPU, do the inference step, return the image or whatever to your Flask app. And then you can show, teddy bear in space or whatever to your users.
Okay. So it is actually, it's not like it'll replace your web server really. It's more so that you're in a Python environment and you want to easily be able to call a GPU. You can just use Modal, pass whatever parameters you want to it, and you'll on the fly spin up whatever function they need to get this working. Yeah.
And I admit it's a little bit confusing because Modal is like so general purpose. Like you can do almost anything. Like you can absolutely do like the web server too in Modal. But like the general pattern is like what people use Modal for is they have some sort of, Gen AI model, typically like some Stable Diffusion or, one of our biggest customers, Suno.ai. They do like AI generated music and they run pretty large scale. So they deploy the model on Modal and then they have some web server running elsewhere that then calls the modal code. Or you can also call it over REST. Like you can set up like a REST endpoint too. That's another way to do it. So modal is more meant for like the GPU inference, and then like the other stuff you can run it on modal too, but that's not like a super core focus of ours.
Got it. Understood. Cool. Well, hey, I kind of want to move over to a little bit of it seems, Erik, that this is an interesting startup in that I feel like you have a very large reliability intensive workload, right? Where your customers like Suno AI and these sort of big ML type customers want to make sure that things are always up, and these are actually very in tune with their business in terms of if it goes down, that kind of will start having people ask questions, right? How do you think about that, and how has that changed from like starting the company to now having a larger team? And are there any general like principles that you've kept to maintain reliability and keep things in check and so on and so forth, but at the expense of perhaps moving not as fast or something like that?
Yeah, because a little bit is like at odds, right? Like at the startup, you want to move extremely quickly and move fast, break things, right? But on the other hand, we're an infrastructure provider, so like we definitely have like a higher bar than other typical startups at our stage, right? And if a normal startup at our stage is fine having like 99.3% uptime or whatever, like whatever, you're just making a number, we have to be much more careful. Like we have to have 99.95%, whatever it is, like much higher uptime. So obviously that is a big challenge for us and something we spend a lot of time on. And I don't know if there's like a magic bullet. Like I think one of the things like just culturally like that's worked reasonably well on that. It obviously, besides like we have very extensive alerting, we have very extensive unit tests, integration tests, we have a lot of synthetic monitors. We do like performance benchmarks against the system like 24/7. But I was going to say also like culturally, I think just creating a culture of like kind of scrutiny and like what I found like more practically like extremely rigid like post-mortem processes is one of the easiest ways to build resilience into the system. Like and that's something we've gotten a lot better at over the last 6 months. Basically, almost any bug in production, we now like write up like an official and not official, we don't share it publicly typically, but like we write up an internal document explaining exactly what happened and what could we have done to prevent this. Like how do we prevent this from happening next time, and what's the root cause, and document a number of follow-up items, and then make sure those have owners. And so there's like a few of those things, right?
Like, are there any particular interesting recent postmortems that are like, and you don't have to be too specific, but I'm curious, like, what sorts of interesting things come up in those types of conversations that I don't know, maybe that you weren't able to do earlier?
Yeah, I mean, there's some like very like classic ones, like some crazy database query causes a lock, and then other database queries can't run, and like the whole database goes down, right? And then you have to just go back and like rethink how you're doing transactions or whatever. Like other types of outages have been more esoteric. Like we run in multiple regions in multiple cloud vendors, and so on a more like a positive note, like something we've done like relatively well is like I think recently a couple of weeks ago we had an outage where an entire cloud vendor went out. And but our system actually, because we were running like we're multi-cloud, multi-region, which I think, by the way, for most startups is a terrible idea. But if you're an infrastructure provider, it's actually kind of a good idea. We were able to like fail over to a new to another cloud vendor like very quickly, like just like minutes. So that's on the flip side. I think like a postmortem, we actually kind of felt like we got to call it like we actually did a pretty good job here. Like our system is pretty resilient. So I don't know. Yeah. It's hard, but it's fun.
Yeah, makes sense. And I imagine it's like a good balance. The whole like very strict postmortem culture is a good balance between moving quickly because it's post the problem happening and making sure that the same problems don't happen again and again. Because I feel like, I mean, we can talk from experience too at our company. It's like you want people to make mistakes, but at the same time, you don't want those mistakes to happen multiple times. And there's always a balance,
Totally, absolutely, and I think a big honestly, like one of the biggest advantages of being a startup, like versus being AWS or something like that, is like AWS, like when they ship something, they have to have, 8 nines of uptime, and they have to, think about every possible failure case. And like we can get away with like a little bit less rigor. And that makes it possible to move very quickly. But what I think is unforgivable is if we fail in the same way twice. Like I think it's okay. Like we fail one time, we like go back and look at like what is wrong with our processes. Like why didn't we catch this bug? But when we fail the same, twice, in the same way, then I'm like, wait a minute, like this is really bad. Like this is, big facepalm.
The next thing I want to talk about, Erik, is like where you see the general data stack, machine learning stack going. We talked a little bit about Airflow and Dagster and Prefect and that sort of world. I'm pretty familiar with that. I imagine, there's the world of Snowflake and big data and all that kind of stuff. But then I feel like the sort of maybe elephant in the room is just where generative AI and that sort of world will go. And perhaps how they're all, intertwined and related. Maybe you can talk to like what you've learned recently with just having more users and more customers on your platform, and maybe other sort of spaces that you find interesting given the new generative AI stack.
Yeah. I always felt that like data kind of has lacked a little bit of an identity and like, their own tool chain for a long time. And for a long time, like, going back like 10 years, like I was the data team at Spotify. Like I was a 1-person data team, and like data was something kind of fringe, like not a lot of people did. But suddenly now it's like, it's suddenly, something a lot of companies are, you have 20 whatever % of the tech team is doing data, machine learning, AI, like, it's a pretty significant part of the tech team in many cases. And so for that reason, I think there's an opportunity to kind of rethink what infrastructure they have, right? Like in the past, like if it's also the case, like data teams want to deploy some machine learning models, like they would go to the platform team. The platform team would be like, well, you can just use Kubernetes just like everyone else. Like just, set it up, like write YAML, like whatever, like define Docker. And for a lot of reasons, it turns out that like the types of things that data, machine learning, AI teams do, it's just not a good fit for like existing, like they do a lot of things, for instance, that are very bursty, like they fan out, scale and then scale up, scale out. They often use GPUs, like, which is like, harder to set up in the like normal traditional infrastructure. And they often have like very, complex like environment, like, getting the right GPU drivers and all that crap. Like it's often a challenge. So I think for a lot of reasons, like it's been challenging for data teams to work with the existing infrastructure. And part of what I saw as an opportunity for Modal is like, okay, well, let's like actually like rethink what it should look like. And in Modal's case, like to me, like the real opportunity here was like, how do we make it easy to actually run everything in the cloud, but still preserve the developer experience you have from running things locally? Because that was really the starting point. It's like, I just want to have like an amazing, super fast feedback loop that enables people to write like, code that uses GPUs or whatever, but like is fast enough, like, where I don't have to, where like I feel like I can actually iterate as quickly as locally. And so I think for a while, like for a long time, like data teams weren't big enough that there was like an opportunity to build this infrastructure. And I also think there wasn't anything that like cost us to break enough what it was worth. But like suddenly what's happened in the last few years is like data teams are getting bigger. And suddenly with like, especially with the emergence of Gen AI, now it's like very clear to me that like traditional infrastructure does not really suit the, fill the needs of data teams. And so that's where I think there's the opportunity to like kind of rethink and say, actually, let's build something better for these needs that are somewhat idiosyncratic.
With users of Modal, is it more often like a traditional data team similar to what you were at Spotify and things like that? Or is it more, the new generation of developers that are building generative AI applications? Or is it just sort of a mix and you think they'll converge over time?
It's more the latter. And I think the reason is that it's so much easier to tell people to use Modal when they don't have anything. When you go to an existing team and they already have a platform, they're using Databricks or SageMaker, or whatever, or Snowpark or something, I don't know. It's harder to get them to move to Modal. And so, I think we're going to, make significant inroads into those areas too over the next few years, more like sort of enterprise platforms. But the real traction we've had so far has been more like greenfield things. It's like early stage startups, they built some amazing machine learning model or amazing AI model. And now they're like, well, we have to deploy this. How do we do this? We don't want to deal with Kubernetes. And then that's where I think, Modal comes in and like, well, you can just use Modal. And then you don't have to think about, scaling and infrastructure and containers and all that stuff. And has that, developer experience that makes it possible for them to focus on what they're good at, which is to train models or build apps, not infrastructure. So that's where we've seen the most traction, is like that sort of, early stage tech teams.
On that note, so you mentioned, people don't want to deal with Kubernetes and they don't want to deal with, low level infrastructure concepts and just a function, right?
Yeah.
How
I want to deal with it, by the way. That's like, that's my like trade.
I was going to ask you about that. So tell me about Modal and how it's built to whatever extent you want to share, right? In terms of like, what is different than me just, for example, spinning up a GPU on a big EC2 box and opening an endpoint to which people can query. You know what I mean?
Yeah, you can do that, but but like, first of all, like, you're going to pay for a lot of idle resources for a long time if you don't have any users. And then suddenly one day you're going to get too many users, and now like the user experience is going to degrade because like your machine can't handle it. So part of what Modal handles is that scaling, right? Like we manage a lot of GPUs. We scale up and down in the cloud. We're in a lot of different regions, a bunch of different cloud vendors. So we handle all that scaling. But to answer like what we all, so that's like something clear that we built. And in fact, we're actually using like mixed integer programming to like, solve for like, how do we allocate cloud resources throughout the day? And we move things between Europe and the US and Canada and a bunch of places to find, as like GPU capacity changes. Another thing we like that we built first was we wanted the ability to take code, put it in a container, and execute it in the cloud in less than a second. Because that's when I feel like that's when you have this like ultra fast like feedback loops that make you happy as an engineer. And so how do you start containers very quickly is a tricky challenge. And what we realized pretty quickly is like, we can't use Docker for this. We can't use Kubernetes. Like, Docker is too slow. Pulling images and pushing images is just very inefficient. And Kubernetes is not fast enough at scheduling things. So we built our own container runtime. Well, we didn't build the low-level stuff. We use initially we used to run C, now we use gvisor. But we built all the stuff around it to like manage these containers and workers. And in fact, we also built our own file system in order to improve containers cold start. We realized a lot of what's really inefficient is like reading files from local to disk. So we ended up building this basically this distributed cache plus a file system that caches as a continuous file system that caches blocks in these containers very efficiently. And that enables us to start containers very quickly. And then we built our own scheduler too. So like, there's a lot of work into also, we manage, like I mentioned, like a few thousand GPUs. How do we allocate containers to workers? And in particular, like, that's a big part of like, our economics is to, we take all these different disparate like user workloads and pack them together in workers. And, we doing that efficiently is another way we can like, lower the cost to customers. So yeah, I mean, like those are all like, very hard infrastructure problem. Like, most of that is in Rust, like pretty low level. We spend a lot of time like dealing with like, I don't know, Linux page cache and all kinds of stuff. And it's a lot of fun. So like, my pitch to people is like, you shouldn't have to think about infrastructure, but like, I can think about infrastructure. Like, I'll solve all these problems for you so that you can focus on what you're good at, which is like maybe training models or building application code or whatever it is.
On the Modal side of things, just like as a user of Modal, can you just have a generic container? And like, are you basically just spinning up and down a single type of container and you don't need to like inject particular like imports and, you know what I mean? Like, how does that work?
I think eventually, right? Like, I think Modal is like almost like two products like bundled into one. Like, one is this like low level, like, container runtime, like you mentioned, but it's like very coupled today with also the Python SDK. And the only way to use Modal is like by defining, writing a bunch of Python code that like interacts with our Python SDK. And that was an intentional choice because like, when I use like Lambda, like one big friction point is like, it's like so decoupled that the developer experience ends up being really janky. Like, you have to like first build a container, then push it to, EC2 or the container registry, ECS, whatever it's called, ECR, I guess. And then like, trigger a Lambda, et cetera. So instead, we basically said, well, like data teams, they all use Python. So let's just like build it all together. And part of the inspiration is like using tools like Pulumi or like Swix. I think like you wrote like an epic blog post about this, like the self-provisioning runtime. It's like the idea is almost like you write code and the code defines, you know, not just like what happens, like the application code, but the code itself also defines its own infrastructure, right? And that was the user experience that I wanted to offer. And like the only way to build that was like to build the SDK at the same time as we built this like container runtime, right? In the future, maybe we'll decouple those, and maybe there's going to be other entry points to using Modal. Maybe, you know, you can run arbitrary container. We've started to play around with that. Like there are ways now to like run like arbitrary things in Modal that are not like in this like Python specific format. But that's sort of like longer term project. Like the main focus is like to make our Python SDK work really well with the container runtime.
Okay, so just to close the loop there, let's use that Flask app example, right?
Yeah.
Where I want to, in the Flask app, in one of these endpoints, say like, I want to have some inputs and get outputs from a model, right?
Yeah.
Is your SDK limited to like just inputting things into a model and reading things out in a model, or can I just write arbitrary Python that gets scheduled on this container as well?
Yeah, pretty much. You can write like arbitrary, but you can write a bunch of different functions calling each other. They're all run in different containers, and you can set up like, you know, this function should be called every hour, or like you can take a function and say, I want to expose this with a REST interface, and now you get exposed to public internet.
Oh, okay. But it happens to be in a Python file.
Yeah, it happens to be in a... Correct. Yeah. So like there's almost like a compiler. I don't know how to explain it, but like you define like Python code, and then like we basically, you know, take that code and like turn that into like, okay, we create all these like functions in the cloud.
Got it.
And like we do that in less than a second. So like that's the other thing. And then we can like launch these things in the cloud.
Got it. Cool.
Yeah.
Cool.
I wish I could like pull up a demo, because like I feel like if I can like show this. Like,
no, I kind of get it. It reminds me of Temporal a little bit.
Temporal, yeah. I mean, Temporal focuses more like more like the building DAGs,
but
right?
Yeah,
and like
the only reason it reminds me of that is because of just the code into infrastructure concept. You know, I mean, I imagine you guys have very different types of customers, and it's not at all similar in terms of the product, but yeah, that's kind of what it reminds me of, I guess.
Yeah, I think Modal goes a level deeper in terms of also like the code in itself like defines like the container that are needed and the hardware, right? Like in Modal, it's like the code itself. You say, run this thing on a GPU. Right. Got it. Anyway, okay. I realize this is like kind of, you know, confusing, but go to modal.com/docs and you can take a look at like some examples. And
Sounds good. Cool. Okay. The next thing that we wanted to cover, Erik, was just some leadership things. You know, I feel like you were a leader at Spotify, and I imagine you've done a lot of more of that kind of stuff in the past. What sorts of things at a fast moving startup have changed or repurposed your thoughts on leadership, and like any sort of fun things you've learned given your time at Modal that you think maybe you could do better in your past, or that you would tell a leader at a startup?
Yeah. I tweeted this thing yesterday. It was like apparently like super controversial, which is like, I kind of realized like code reviews should not be mandated. And I didn't think that was like so contentious, but like a lot of people, because I look back, like that was like one of the sort of things I used to have like a very dogmatic belief, like code reviews are like, you know, a must. But like, you know, at Modal, like we don't review most code. Like we have like instead like extremely extensive CI pipeline. We do a lot of like post-merge reviews. So that's just like one example. I mean, maybe it's like kind of a minor thing, but it was just funny. Like it's one of the things like I've actually changed a lot in terms of like how I think about. I don't know. Like in general, I would say like early stage startups, what I've learned through my time at Spotify and other places and Modal is that I think of it as like minimum viable bureaucracy. Like there is like a minimum set of things you need, a minimum amount of processes. And that obviously goes up the bigger you get. But for most companies, and especially at an early stage, that amount of bureaucracy could be almost non-existent, like, or a lot less than what people think. So you always want to hold back. And what I found is like you hire a bunch of smart people, scrappy people that have like a deep commercial instinct. Like my job is to not like tell people what to do. It's like to tell people like, here are the goals. Like here's what the company is trying to achieve. And then kind of let people self-organize and be autonomous. And I want people to come in every morning and just ask themselves, what's the like number one thing I could do for the company, and kind of just like, act on that. And, so in a way, like, I think my sort of highest, like most, fuzzy principle of management is like, I kind of need to make myself redundant in a way. Like, anything I do, anything when I'm needed, I kind of need to figure out like, well, how do I make myself not needed for this? Because that's the only way to scale. So I don't know. So that's like, to me, like the number one way to see that I've seen like early stage startup culture is like, just hire a lot of smart people and just like, let them kind of self-organize.
That seems really dependent on being able to hire really smart people, right? Like there's got to be a pretty high bar.
Totally. Yeah. And like, some people may say this is like super aspirational and naive. And to some extent it is. But then like to me, like the question is like, well, at least like, how do I get as close to that as possible, right? Like it might not be possible to like completely take a backseat role and do nothing, but like, what's the least amount of thing I need to do to like get these people to like self-organize? And that turns out to be not that much. Like you can do a lot less in terms of process. Like we basically don't have meetings at Modal. Like we don't have like OKRs. We don't do sprints. Like we don't, we have stuff in the linear, but very little sort of like we don't do burn down charts, any of that nonsense, right? Like
What's your approach to interviewing candidates, especially like lead code versus just talking to people?
Yeah. At a high level, like I actually don't care. Like, I mean, like my feeling is like interviewing is like a very noisy problem. Like you have like a few hours. You're going to spend a few hours with a candidate and you're trying to predict, is this person going to be successful or not? What is the like highest signal to noise thing that I can do to predict whether this person is going to succeed? I think I'm not like a big advocate for lead code. I think lead code is kind of terrible, but I think people object to lead code on like weird grounds, which is like, oh, like why do lead code? No one's doing lead code in the real work. But that's actually the wrong way to think about it. The right way to think about it is like, is this thing predictive of whether this person is going to be good in the future? Like if someone told me like the best way to predict, future success is to do lead code, I would totally do lead code. I don't think it is, but I think that's like, the way to think about it. So like in my case, like what I found is like lead code, like, not really good signal, but also like talking to people, like open-ended conversation. I mean, there's like research on this. Like this is not very predictive. IQ tests like actually turns out to be pretty predictive, but they're illegal, so you can't do that. What I found like in my case to work reasonably well is to do code reading. And the reason why I like code reading is like if I print a bunch of code snippets, you can actually cover quite a lot of them in a short time frame. Like you can have like a 10-line Python code, you can have a 10-line JavaScript code, 10-line whatever, PHP or Rust or whatever. Doesn't even matter. Like smart people, like even though they don't know the language, will kind of pick it up and like kind of figure it out. And then you can talk about, okay, what does this code do? How does it work? Maybe there's a bug in the code. Can you figure it out? What's causing, there's an edge case, maybe it doesn't work. What I like about that is that you can cover a lot of ground very quickly, which means like the signal to noise is higher, right? Like, if you have time to do 5 code snippets, then to some extent you get a little bit more like independent signals, which is, from like a statistics point of view, like means you sort of, decorrelate the noise to some extent and like have some higher say. So that's like one thing I like to do. I like to do system design a little bit, talk more about like, okay, how would you build this system? More because like I want to hear people structure, kind of think through like how to structure things. To the extent I have open-ended conversations, like the only thing I like to do would be like something like kind of have people talk to me about like, what's the hardest thing you've ever built? And then I like to pick something like kind of almost like arbitrary and say, why did you do this? And like, okay. And then I go to a level deeper and then they're like, well, you could have done this, like, and then like, I want to hear people like, almost like rationalize like a particular detail or a particular design. Cause that to me, like tells me like, okay, they actually like thought about this. They actually put a lot of effort into like, making a thorough decision. And that's something I like to hear.
I've had a good experience just picking people's brains and like talking to them about like their philosophy and how they approach problems in general and like how how they like work with the language we're working with, just to try to gauge their level.
I think what you want to watch out for in that case is like some people are just very good at presenting themselves. And so you need to figure out like, okay, like some people are just very polished, right? Like they're just, very eloquent and they can like talk a lot. Like, and that's like the thing I think, in that case, like you need to be careful to make sure, how do you make sure kind of separate those things? Like, some person may just be very good at like presenting themselves. And, so when you have these like soft questions, but I agree with you, like, starting with that and then kind of drilling down into certain things, like it is a good way to like gauge someone's like experience level and skill level and like make sure, have they really built hard things?
I've worked in JavaScript for years and years and years. And I feel like there's a progression people go through as they sort of get into the depths of this crazy language ecosystem. And just by talking to people, I can figure out pretty quickly how deep they've gone.
Yeah. I mean, a silly thing is like on that note is like I often find like a red flag is like people that have like very dogmatic beliefs. Like I feel like when they, like with experienced people, it's always like it depends. That's always like a flag in itself. Like when I hear that, I'm like, yeah, this person is like seeing everything.
Oh, I was going to mention that like I feel like the leak code stuff to me is almost like the SAT.
Yeah, but the SAT is the most predictive thing that you can use in like university assessments. So like, I don't know, maybe it's good.
That's what I'm saying.
The SAT is like, basically an IQ test.
Yeah. I think actually leak code to an extent is that, plus you need to put the time in. Yeah. And obviously you'll get candidates that are maybe not super intelligent, but put a shit ton of time in. Or you'll get people that haven't put much time in, but are very intelligent. And that's perhaps better than just a conversation, like, so I feel like there's a lot of talk about anti-leak code or whatever, but I mean, I am definitely pro code, like people should code in front of you and you should understand how they're thinking through the code, like you say, Eric. But it's almost like it needs to be something that's like normalized, just like there is an SAT or something like that. I don't know.
Yeah.
It's a tough.
I mean, for what it's worth, I do think people like some people who are very good at lead code are very good engineers, right? And I would say a similar thing would be like people have like extensive, GitHub presence. Like, and it's not that like, I've hired like some amazing people who have like absolutely nothing on their GitHub. But of course, like when I see someone who has like a lot of like successful open source projects, it is a good factor. Like, I'm not going to lie, like that is a very significant factor. And like, I get excited about that. But, but again, like the absence may not actually be, a red flag. Like there are some people, amazing engineers who like never built an open source project.
How many engineers are on your team, Eric, right now?
15 right now.
And how do you, has the interview process changed as the team has grown?
Yeah, because I think a lot of the hires have actually been so far through our own network. And so I think it's been more lightweight for that reason. Which in general, I actually think it's bad. Like I don't advocate for having a lightweight process. It's just that like a lot of the people we hired so far are actually people we work with. Like I worked with in the past. So like in that case, like I'm not going to interview them really. Like I know they're good. But like now that we're starting to kind of go beyond that, like we're adding a little bit more structure, which I think is important. It is important to have structured interview process.
And what do you think that'll look like? Will it be like a leak code-esque thing? Will it be more code reading? Like,
I like code reading. I like system design. I like, I occasionally use lead code more for like, because the truth is like one challenge, is like you get a lot of people applying, a lot of new grads. And like, I don't frankly like have time to like talk to all of them. So in those cases, like I'll send them, a lot of those, but I try to pick problems that are not like necessarily like implement, whatever Dijkstra's algorithm. Like, cause I think those are a little bit silly. It's more like real world thing. Like what I think is like, often like indicative of experiences, like wrangling with like dates, like stuff like that. Right. Like I kind of like those problems.
Cool. Well, okay, Eric, let's finish off with a few random questions that Esplin has been kind enough to ask to dig through your Twitter to find. First question is, what is your favorite marinara sauce?
In a jar, it's definitely Rayo's, like by far.
Oh, how do you spell that? Oh, Rayo.
R-A-O.
I've never had that. Do they have that on like most
They have it at like Whole Foods and actually like most like stores will have Rayo's. I think it's by far the best. Like,
I've recently had the Trader Joe's garlic marinara. It's pretty good. I would recommend trying it. I would recommend.
I'll check it
Have
out.
you had the Rails, Jay?
I haven't. Have you, Chris?
Oh yeah, it's very expensive and it's head and shoulders above everything else. It's up.
I should try it. That's the next one I'm trying. Cool. Second question is, I'm trying to read this and not laugh, but what is your opinion on laundry machines and what they should be like in the US?
You've been like digging through my like Twitter like shit posting. Yeah, no, I was in Sweden the other day and like I tweeted something because I was in my dad's, I was doing laundry at my dad's and they have this like amazing like cabinets there that I love. Which are like big, like it's like a whole closet and then you hang your stuff up in it and it dries it and it's like wrinkle free.
Oh wow.
Those are great. I love those. No one has them in the US, but they should.
But they take up so much space.
They do take up a lot of space.
Yeah. Makes sense.
Do your clothes come out like ironed?
I mean, not ironed, but like you hang them up and then like they're like in this like, cabinet that like sucks up the humidity. And so they come out like kind of like not very wrinkled at all.
I'm jealous.
I was in Japan for a month and they have it's very common for there to be a washer dryer in a single machine.
Yeah, I have that at home, but yeah, like it gets very wrinkled.
Yeah. It's fair. Makes sense. Okay, and then last question is, what's the hardest part of teaching your kids Swedish?
That is a good question. I have 2 kids, and Swedish is such an internationally useful language that I decided I'm going to teach. It opens so many doors. No, not at all. But I think, it's like a kind of, fun part of the identity. And I wanted to teach them that. And I want them to, go to Sweden and have that optionality.
Nice.
So, yeah, so I decided to teach them Swedish. And I think it's actually not that hard, frankly, like, because I speak it. And so I almost like question like why I would not do it. Like, for me, it's easier to speak Swedish with my kid. Initially, it's a little bit annoying, like, because they like to talk back in English. That's like, so that's a little bit of a hurdle. But then, you basically just like tell them, like one thing I used to do was like they would speak back to me in English. I would then switch to German and like just to piss them off. And then like after a while they would learn. So they're like, okay, fine. And now they're like, it's just, how they talk to me. They talk to me in Swedish and I speak to them in Swedish. And then they kind of, learn. I would say like, it's not quite at their English. I mean, they're born and raised in the US, but it's like 70% of their English.
That's really good to hear. Because I know someone who speaks Portuguese as a second language, and he's trying to do the same thing with his kids, teaching them Brazilian Portuguese. Yeah, and I think it's much harder just because he doesn't speak it as well as if he were native.
Yeah.
Oh, interesting. But yeah, I guess for Erik, it comes naturally.
Yeah, but I mean, I would say like every parent that like speaks, English is not their native language and they live in the US, like should, in my opinion, speak that language with their kids and make them speak it back too.
Yeah. Interesting. Cool. Well, hey, Erik, thank you for coming to the podcast.
Yeah, it's fun.
Sorry if it was a little rough towards the beginning. I was shuffling a lot of documents. I don't know if you
No, it's great. I enjoyed it. I had a lot of fun.